Okay, so hi all. So this is going to be our day 3 of Google Cloud Fundamentals session. Today we are going to discuss or we are going to cover about the this is going to be a continuation of our previous session. So we are going to cover Google Kubernetes engine, cloud functions, cloud run, and then we'll discuss when to choose which service, right? So based on what which case you should be selecting what services, and we'll also try to cover a lab. Okay, definitely that should be something that we want to spend a little extra time. But yes, I will explain it once, and then you can go through it after the session. And tomorrow we'll again try to cover whatever is not clear to you. Okay, so let's get started then. Okay, fine. So the topic that we want to discuss now is for Kubernetes, as we had planned for. But even before I go to Kubernetes, there are two concepts that we want to touch and then come back to the Kubernetes. Okay, so let's go to the second slide. Oh, give me a second. Did I miss it somewhere? Give me a second. No? Okay, so let's share the other screen. Yes. So I wanted to explain you with the help of this uh, architecture. Okay. So here, if you see, there are a lot many services involved. This is basically a CI/CD pipeline to deploy your components, your application to Kubernetes. Okay, so you will have Kubernetes deploy. I mean, the applications deployed to the Google Kubernetes engine. Okay, that's the containerized application that we want to deploy. Now, what all components you are seeing here? We can see GitHub, right? There is a developer who is actually developing the code. Okay, and we see cloud build artifacts, deploy artifacts. Okay, there is a build phase, cloud build phase, which is going to create the container out of the code that you have created. When I say container, it's nothing but a microservice that it is going to create, which you deploy to GKE. Okay, and so let's come back to this GitHub part first. So in the GitHub, you are going to keep your repos, the code that you are going to deploy, I mean develop, that you are going to keep in a GitHub, right? GitHub or maybe some other repository that you may be using. So developer will go and access the Cloud Shell. Do we remember that where is Cloud Shell? Where you can find it?
In the corner, which we have already clicked in the screen, console screen.
Yes.
Okay. So in the console, you had the Cloud Run. I mean the Cloud Shell, right?
Yes,
Now
yes.
this Cloud Shell, if you are able to see here, okay. Am I not sharing full screen? Okay, give me a second. Let me share the full screen then.
It is not in full zoom.
Yeah, okay, no problem. Okay, so now you must be seeing it.
Yes.
So in this complete architecture, we have a developer who is going to access the Cloud Shell, and in the Cloud Shell, you will get an editor. If I click on this, I do have the terminal, but I also have access to a editor. Okay, I'm just running it up.
Okay.
And you can basically integrate it with VBA or any other, I mean, Visual Studio or any other third-party tool. You can definitely integrate it, but it already has a lot much of integration where you can perform all sort of operation. You can write your code, you can test it out, right? So this is the component of cloud build or cloud code, okay, where you which will help you to easily write your codes. Okay, it has integration with the Terraform as well. Okay, which definitely helps you in creating the code. So you are actually creating your code using the cloud code on the Cloud Shell environment. Once the code is created, you are going to keep that as a in the repository. The repo that you are creating is going to be GitHub, or you can have Google Cloud's own repository. It's a private Git repo, you can say. Okay, so cloud source repository is nothing but Google's. It's a GitHub, but privately hosted on Google Cloud. Okay, so far clear. Now, once you have created it, there will be triggers created. Okay, now these triggers are actually created through cloud functions. We'll be talking about, when we are going to talk about cloud function, you will understand that how they are triggered, even not only through the cloud function, but there can be other ways of triggering it. But just take this as a use case where you can relate also how the cloud function is working. Okay, so here it is going to be trigger. It will go trigger a function. That function is going to call the cloud build. So cloud build, what it is going to do, it is going to actually create a image out of the code that you have written. When I say image, so image is nothing but the operating, I mean, which is going to create the container. So there are three steps. You have a text file, a code, or you can say a Docker file. Okay. Now that Docker file is going to be created as an image using the cloud build. Okay, and then cloud build is actually going to create a container also for you. That container will be deployed, okay, using the Google Cloud Deploy. Yeah, so using Google Cloud Deploy, it is going to be deployed to any environment. It can be Cloud Run, it can be Compute Engine as well, it can be even the App Engine, or it can be even the GKE. In this scenario, we are talking about GKE, right? So here, once all these steps are done, I'm going to deploy my microservice or the container to GKE, right? And also you see there is a step where the artifacts are stored here. So these artifacts are nothing but the image that we create out of those uh, the Docker file, right? So now the Docker file which we have used for creating the image, that will be saved somewhere in the artifact registry. So it will be there as long as there is there is this application which is going to be uh, uh, calling the image whenever there is a need, right? Because we are working with the microservices. So microservices will be like we can have tens and thousands of applications can be running and using the same image all the time, right? So we want to store it somewhere, and that is where the artifact registry is used. So it will be directly interacting with the GKE, and GKE is going to use that image for deployments. Okay. Now also there is another step. This is for staging area, like development and staging only. But when we are deploying to production, okay, that is where we need an approval. So operations team will come here, who is going to look into all these steps and then identify, okay, why they are deploying, if they it is validated completely, if there is any security concern, everything will be validated first, and based on those inputs, they are going to approve or decline the deployment in production, right? So even this can also be automated, but yes, there is a approval process, and after that only we are deploying anything to production. Okay. And there is another part. So build artifacts are also stored in the cloud storage, and the deploy artifacts are stored in the cloud storage, right? So whenever we are talking about the artifacts, these are the that can be containers or the images that we are creating out of this build, or there can be some metadata around it. Okay, all of that will be stored into the cloud storage. Okay, so far on very high level, did you get some clarity where this complete architecture, how it works whenever we are working with any of Kubernetes aspect here we are talking about. So from Kubernetes aspect, did we get some clarity how this deployment is working, the end-to-end cycle? Or anyone has any question before I move forward?
So as per this diagram, if suppose that anyone or any interview they have asked, can you draw the diagram of Kubernetes, how any application is going to deploy? On that basis, we can explain this architecture. Is it fine?
Yes, you can explain this architecture. As long as you can explain this architecture, that will build your confidence to the interview.
Okay.
Yeah.
Okay. So I will tell. Okay. In GitHub, first developer will create the code. Okay. And he can write in the separately also.
Right.
Not here itself. Correct?
Yes.
Okay. So suppose that is the Python script. So he will write in the Python code. Okay. And they can directly keep in the cloud code. Correct?
Right.
Okay. After that, it will go to the cloud resource repository. Correct? After that, it will trigger. Some commands will be there in everywhere. Yeah. Am I right?
Yes.
Okay. So after that, it will go to the build and test in the cloud build. That is also, this is also one tool, correct? In the GCP.
Yes. This is another service provided by Google Cloud. Yes.
Okay. Cloud build. Okay. That is CI tool, right. I can say. Yeah. Okay.
Yes.
After that, it will go for the artifact in the bottom, or it will go to in the build artifact.
Both the steps. So this both step will work. So this is
both will go or one places.
No. See, it is going to go in two places, right? So either you are creating a new image, or you are taking a image already created in earlier steps, right? So that will be there, which you can take from the artifact registry itself, right?
But until unless we have not created, how it will go there?
No, until unless you have not created, it will not go there. So that's what you cannot have an image already existing, or you cannot access artifact registry unless you have run the cloud build for at least one time.
Okay. No, so that is first time we are doing everything. Okay. So we will run that one. Okay.
Yes.
Cloud build, once we will run, it will go to the artifactory registry.
Right.
Correct. After that, it will go in the staging cluster.
Right.
Okay, and that is called GKE, Google Kubernetes Engine, correct?
Yes, that's true.
Okay. Now, after that, it will go to the production cluster, correct?
Okay, so production is a next step, like always it happens, right? So whatever you're going to develop, that you want to actually deploy to production so that the end user can use it, right?
Yes.
So for that, we should have the another, further step where you are going to ensure that these applications are also getting deployed to production, right?
Okay. No, but here diagram, as per the diagram, it is showing like that a staging cluster will be in the center, but in the staging cluster, it is not going anywhere.
Yes.
Okay.
Yeah, they are two separate clusters actually. So Raju, these are two different environments, right?
Okay.
So whenever you are working with any of the application development process, you will have development environment, you will have the staging for testing purpose, and there will be one more environment for production. You can directly go to CI/CD application and directly deploy your application to production also, right? I mean, if you have already tested out everything, and you have you are sure that everything is working fine in staging, you want to use the same pipeline for deploying your application to production as well.
Okay, but here arrow is not given. It means that arrow should be vice versa. Google Cloud deploy.
No, which arrow?
Here, I will tell you. CI build and test is there. Okay. Okay. After that, it will go to CD deploy.
Yes.
Okay. And another also option is there. It is going to artifact registry. Two options are there. If suppose that we will go through this one, a staging cluster. After that, where we will go?
No, you don't have to go anywhere. No, staging is for staging only. I mean, that is only for testing purpose. Like you have a lower environment. See, you are working in production all the time.
Okay. Got it.
Right.
Okay. So here two option is there. So I think this arrow should not be there. I think.
Which arrow?
Google Cloud display deploy and a staging cluster. Okay, it will go in both the way. Okay.
Yes.
Got it.
Rajiv, like in staging, we will be verifying, and after verification is completed, right? So manually we will approve that, and after
Okay.
that
Yes.
only it will go to production cluster.
So just
Okay.
take it this way, Rajiv. These are two separate processes, but
Okay.
they have a commonality that the CI and CD part will remain same. Only
Okay.
difference that you are seeing, the staging and the production clusters are a different environments. Even you have product development also a separate environment, right? So
Okay.
all of these are a separate environments.
Okay. Okay. Now I
But
got it. Okay.
yeah,
Actually, Google Cloud deploy and application container. It should go in the both the way. So only it was showing in a staging cluster. So my mistake was there. It
no,
should be
it
in
is
both
going
the
for
center.
both. See this.
Yes, yes,
Okay, so
going. I got it. I got it.
yeah, okay,
Got it.
that's
Got
fine.
it.
Okay, so now if you try to explore it a bit more, so we will have a kind of free hand in development cluster, right? So you are testing, I mean, developing your code, you are doing all sort of things. They are not going to have a bigger machines, but staging and production clusters are going to be somewhat similar. But yeah, staging will not be to the extent of what production has the capacity or the workload that it can take the kind of containers that we are running. Okay, so otherwise everything will remain same in staging and production, because staging is something that we want to have a parallel environment compared to production, but here it is only for the testing purpose. We are not exposing this for the client, for the users. Okay. Okay, anyone has any other question here?
Jitendra, sorry, I joined late on the call. Uh, I believe I missed the initial 10-15 minutes, but then I could somewhat understand this architecture. But only thing I couldn't understand is this operation approval, which
Mhm.
is apart from this side, like, where this comes in picture when this
Okay,
process.
this is only for production environment. In production, we do not allow everyone to come and deploy anything, right? We don't
Yeah.
let anyone touch it otherwise. So there will be operations team which will take care of deployments in production. So they will review
Okay.
it and then only the changes are deployed.
Okay.
Yeah, clear?
Yeah.
Don't over, yeah. So I would suggest everyone, don't overthink. This is very simplified architecture, not much to be confusing. Yeah.
Yeah, I agree, but it was on a separate thing. Like it was not connected to any other. Uh, Only the production cluster it was connected. So
Yes.
I was little
Yeah, it
confused
is
on that.
right. It is only limited to production, because in production only we want to ensure there is a proper approval process in place. Okay, before we deploy anything. Yeah.
Okay. Yeah, got it.
Okay. Fine. So let's move on. Come back to our slides. Okay. So now let's see. So we discussed about this architecture, right? Now let's move next. Okay. So the next component is for going deeper into the Kubernetes. But even before it, let's talk about Docker first. So I will share a separate screen here. Okay, let me stop sharing. Fine. So you can see my screen, right? The other screen should be coming now. You can see it?
Yes, we can see it.
Okay. So now if you see, this is for explaining you somewhat of Docker before I move to the Kubernetes back. Okay. Now in Docker, this is nothing but a containerization platform. So you will have a plain text file, something like, let me show here. Okay. So if you see, this is a containerized file, I mean the Docker file. So whenever we are working with Docker, it will require by default, there will be a file named Docker file, and it should look similar to this only. It cannot be changed. It cannot be different. Okay. So now in the Docker file, you are going to declare which image I am going to take. So it will ask for a base image with which you are going to create your application or the image that you are building, the operating system that you are going to create. Okay, fine. So here I have a base image of Python. This is a container or the microservice that I'm going to create for getting a Python interactive shell. Not much harder part. Okay. So I'm taking a base image of Python, and then I'm going to just give it the cmd command so that whenever it is going to start running. Okay, so whenever this operating system, this container or the microservice starts executing, it will only give me a interactive shell as command line where I am going to just execute some Python commands, nothing more. Okay, so the weight of this service is going to be very less. Now if I try to compare it, okay, let me see if I have another screen. Okay. Yeah, so here, this is a Docker application. Okay. Now this application I have installed on Windows system. So earlier, if you remember, you must have, if anyone has given a try, so you must have tried out with some virtual box or something like that, right? But with Docker, you can actually get even much smaller size of images or the virtual machine, which will only have the required components. Like in this scenario, I have a Python interactive shell, nothing else. I mean, it is not going to be loaded with all other set of application which comes up with a complete full-fledged operating system, right? So only thing that I'm going to include is a Python interactive shell. This operating system is going to be hardly few MBs. Okay. So otherwise, if you did not had access to any Linux machine or the Mac operating system, you could not access this kind of command line operations or the Python easily on the Windows system, right? But here I have this opportunity. I can run as many as operating system I want with much of ease.
Docker
So
you have installed in your Windows system?
sorry.
Docker you have installed in your Windows system?
Yes, Docker I have installed on my Windows system.
Okay. After that, screen is coming Notepad++ in that.
No, that's a different application. I mean, Notepad++ is a different tool, right?
You are showing like that.
Yeah, I mean, just this is a different tool. Okay, you can see that, right? Okay, is that clear?
But please explain us to install the same way, then we can practice these things.
Okay, installation is a separate process, Rajiv, that will take maybe 2 hours, I mean 1 or 2 hours to explain a whole the process. I can give you a link how to install it. It's a very simple installation that will be like you can have .exe file and then you can install it. Only concern is that you should have a right configuration of your laptop, like at least you need 8 GB of RAM, right?
That I have.
Okay. Yeah. Apart from that, obviously with that you will get enough memory as well. So that should be all that you need. Okay. So once you install it, it is very much updated version of Docker desktop now. Earlier it was very primitive and you did not have so many functionalities. Now, if you see with Docker installation, what you can get is you have these images, what I'm showing here, right?
Yes.
These images are created out of Docker file. Okay. This Docker file is actually converted into the images. I will show you the command that we use for running that, creating that. Okay. So there is a command called docker build. So let me see where I am currently. Okay, let's go to the path where this file is present. It's in the desktop. Oh, sorry. Yes. So this is a Windows 1 so dir command, right? Now I have this Docker file, right? So wherever this Docker file is present in your system, that is where you need to run Docker and build. You need to give the name of the image that you want to build. So let's suppose I want to give it a, yeah, let me just take the command itself directly, that will be better. Okay. Now this particular command docker build, and this is going to be a tag for the image that I'm going to create. Okay, so it is going to create a image for Python interpreter using the Docker file which is present in this path, right? So there is a dot for that particular folder where I'm going to create it. Okay. Now, as soon as I enter it, it is now going to build a Python interactive shell for me. So it will try to capture all those libraries, everything. If it is already present on my system, then it will just use that immediately. Otherwise, it will try to download it from the internet. Okay. And it is actually creating different layers for security purpose. So you will have different layers for each step. Okay. Now I want to see whether that Docker image that I wanted to create, if it is created or not. So for that the command would be docker images. Okay. Okay. Now what was the name of the Docker image that I have created? This was Python interpreter, right? So once the image is created, okay. So what is that image? This image I'm talking about. Here I will see those images, right? So now it should be listing here, right? You can see it. So now this image is present, and I want to use this image for executing any of the Python programs or any sort of operation I want to perform. So out of the image, now I will be running it so that a container or the microservice can be up and running. I can use it immediately. So whenever I want to whenever I'm going to execute it, let's see. I got the image. Okay. Now let's execute this particular file using the docker run command. Okay. So docker run. So if I try to break up this particular command, it says docker run interactive. So IT is going to be interactive cell, and then Python interpreter is the image name of the image I am going to use for running this particular container. Okay. As you can see, as soon as I executed it, it will give me a interactive Python shell, okay, which I can run any of the commands. So import any modules or Python version I can try to find out. Yeah. So any of it, it's not defined, but yeah, that's how it works. Okay. So next is, yeah. So now you can see here, it should have execute. Yes. If you see, this particular image is now converted into a container and it is up and running. I can utilize it for any of the tasks I want to perform. Okay, this is pretty much very small image just for sample testing. But if you want to learn more in detail about Docker, I would suggest you give me a second. So this is a Docker Hub. I am going to share all of those links, whatever I'm explaining today. So I will share all of these links with you. Okay. So Docker Hub is a place where you can get all of the repository about any application or small or big or any microservice that you want to create, the images, the Docker file that you can get here. This is Docker Hub. Okay, you can see the verified ones or the Docker official images like that. So here you can find for Nginx or MongoDB, whatever sort of things, applications that you can think of, it you can find it here. It's a huge library, even for MySQL database. Okay, so all of this you can find it here. What are steps we need to do? We have to create a Docker file. Here in this scenario, you don't have to create the Docker file because these are already a verified image. You can just take it and run the Docker run command, and you can start using it immediately. You don't have to perform all those sort of operations, right? So Vishal, for you, it is going to be much easier comparatively, if I say, because you don't have to actually go through all the pain of coding and all. You just need a few list of command and you can start using it for any applications that you want to build on.
Yes.
Okay.
Sure. Yeah.
Makes sense?
Yes.
Okay. Now, so far, any question for Docker thing? I mean, before I move forward, just put me few questions if you want. Otherwise, I'll move to the Docker part.
Okay, so in the Docker, we are installing the Docker in the Windows system. Okay, in that we have created one Python interactive session. Okay, in that we will install or we will try to do the coding.
Yes.
Okay, what is the benefit of that? Can you explain that one?
Okay, so benefit is that, as say, you have a very capsulized or very minimized set of operating system available, where you
Okay.
can do all sort of coding. You can perform all the operation, and there are a ways that you can actually persist all of those code in your virtual, I mean, in your local system as well. So there are multiple other operations steps available. So there is the concept of persistent volume, right? That is like a virtual volume that you connect from your local system to this operating system or the microservice that we are running here, right? So now, once I'm done with this, right, I'm going to stop it. Okay, and this operating system is gone, my load is gone. I'm not going to wait for it to that I mean, it is not going to be there for all the time, so that my system is not going to get slow. I can have the minimal configuration and I can keep on building applications easily. Also, the major advantage is that you can actually export it without any issues, and this code is going to work in other system also, because it is not built only with the specification your operating system has, but it is built on the a container which will be similar on multiple platforms. So the portability is the word that I want to say here. So it is portable, right? So the code is going to work anywhere you take it.
Okay, in that scenario, suppose that we are directly creating in Windows system, we are installing the Python. Okay, and we are creating the code, whatever we want to do on that. So
Right.
that code we cannot copy paste in whenever we need, wherever we
You
need.
can do it.
So
You
what
can do
is
it.
the
That's
role of Docker then?
okay. So when you are working with your own operating system, right? So it
Okay.
will say that I have so and so a minimal requirement of the Python module. Okay.
Okay.
So and so requirement of JavaScript, so and so requirement of the other application, right?
Okay.
Now unless you fulfill that, you cannot start working on those applications on your operating system, your own local operating system,
Correct.
right? But
Okay.
with the containerization of these services, okay, using the Docker and the Kubernetes, you can easily work on it without worrying about what your system is having the configuration, right?
Okay. So in that term, suppose that your RAM size to run the Python or any application,
Mhm.
8 GB RAM in the Docker, maybe it need only 1 GB RAM. Am I right?
See, this is only for installation of the whole application. I mean, this particular whole software itself, right? But the one that you are developing here, the images you are developing here, it is only going to be few MBs. You see here, this Nginx machine is only for 142 MB,
Okay.
right? And if I enhance it even better, I can reduce it to even 10x less than this image.
Okay.
Okay, so there are a lot many best practices.
Okay. So inside Docker, we can create multiple images as per our requirement.
Yes.
And
Okay,
that can be transferred in whenever, wherever, whatever the system is there, we can transfer that one. That will be
right,
the
right.
portability facility on that.
Yes, and here you are encapsulating only individual application. So suppose I want only a database. So
Okay.
and I want to actually interact with the other application code in a different microservice, right? So
Okay.
here not only the portability, but the way you are going to communicate with these applications, these components, that will also differ. I mean, suppose you are working on, I mean, you have already created all this picture, you have deployed it to GKE in staging or production that we have seen in the previous architecture. Now, whenever there is an concern, there is an issue with any of the components, you are only going to work with that part of the component, right? I mean, you are going to check only the application, not the database, because database is a separate component completely. It's a different microservice,
Okay.
right?
Okay.
So that modularity you are getting, that flexibility you are getting, okay?
Okay. So
And that's the reason, yeah.
all are microservices, we can say like that. Correct?
Yes, yes,
Python
that's
is
how.
separate and Nginx is different. Grafana is different.
Yes,
Okay.
Grafana is a monitoring tool, right?
Yes, yes,
So
I
that will,
have worked on that.
yeah, okay. So that is all about the high level and good base that I wanted to develop for you, that how the microservices are created, what is Docker, okay, how you actually create your image out of the Docker, okay. Then I have also shown you in the previous architecture. Let me now move back. Okay, so let's come back to our slide now.
Oh, can I ask one question here?
Yes, go ahead.
So, what I just understood is that container is an image consisting of the entire application, it's all the libraries and its interdependencies together.
Right.
And now we are seeing that the images that we are building using this Docker are very small. You said 146 MB.
Yes, yes.
Now, is this normal? Because
This is
normally
normal.
the software is very big, no?
Okay, so see, it is normal, and that is how we create the microservices. Now, when you are talking about an application, which you have seen with the monolithic kind of way, where it is going to be very huge, right? What you see in earlier. Now here you are not loading everything all together in one one container, but you are having multiple small microservices. So suppose one application has a front end, a back end, there is a database involved. Now all of these components are actually created separately when you are working with microservices. Okay. So
Okay.
they are individuals created Now, why I brought this architecture again? So when I was explaining about Docker, so you can consider Docker as here you have this cloud build. I mean, not the cloud build. Cloud build is actually for you can say, yeah, it will create the images, but also it works as a Jenkins pipeline. Also, you can compare. Okay, so it helps in creating the images, and it will store that images into artifact registry, which you saw in Docker. So you saw the images, right? And
Yes.
and that image is now converted into a container and deployed to GKE. In case of Docker, it was deployed in Docker itself, right? Docker application itself. Here it is deployed in the GKE. Now, in case of Docker also, it can be deployed to Kubernetes. Okay. So that Kubernetes is an open source model. This is for the Google's own GKE, Google provided Kubernetes engine.
So
Fine.
normally, like if I deploy the entire application as an image, would you say that size on a normal laptop and size on the image, there is lot of difference?
Yes, yeah, it is going to be a lot of difference, but also it's not a good practice to deploy all of components together. I mean, club all of the components together and deploy.
Okay.
If you are going to do that, there is no point of you creating a microservice, right? Because you are losing the flexibility. You are losing the portability that you were able to do otherwise, right?
Because I'm thinking my company,
Mm-hmm.
there is one application called Portainer. Portainer is being used,
Mm-hmm.
and it has called a server integration server,
Right.
and that server full data you can see while running the application inside this Portainer also. So
Mm-hmm.
my thinking was that everything that is happening in production is there inside this container. Now you are telling me that this might not be true. There is like only partial
Yes.
microservice.
So when the integration is performed, there are multiple of it is actually deployed. Okay. Now let's look it into this particular architecture. Okay. I mean, in this particular graphics, how the Kubernetes is working. Okay.
Okay.
Before I'm moving forward again, let me know anyone has any sort of questions, any concern. Everything is clear?
Yeah.
Yes, sir. Tell me.
No, nothing magic. You can carry on. Docker, I had some doubt, but I think yeah, once you complete this portion, maybe I'll just see if that doubt is still there or not.
Okay, sure. Yeah. Okay, so let me get this enlarged first. I will share a different window. Give me a second.
Jitendra, can you tell just what is the use of Docker and Kubernetes? Not get any. I missed some part of it. I think.
Okay, so what is the question, Vijay?
Docker, Kubernetes. Why we are using in the deployment, or why we are doing that? What is the utilization of Docker, Kubernetes?
Sure, I will tell you. Okay, give me a second. Let me go back and share this architecture. Yeah. Okay, let me know if you are seeing the GKE graphics now. You can see that?
Yes.
Yes.
Okay. Now let's see why we need it. Let's go with this cartoon. So suppose you are working on premises. Okay, you have applications running in production. Now there is some sort of application got crashed, and now you need to actually look into in each and every log to identify where is the error, right? So that is how the monolithic applications were built. So it is a lot of pain, and it takes a few days to actually resolve just a simple issue maybe. Okay. When there was such a concern, so we got into a scenario, okay, why don't we create a container for individual services? Okay. So suppose I have a three-tier architecture. I have a front end, I have a back end, and I have a database running behind the scene, behind the backends, right? So why can't I actually create individual components for it? I mean, I want to deploy front end in a separate container, separate operating system you can consider, or virtual machine, and I have the databases in a separate tier, and also the backend in a separate one. Okay. So if I get such a flexibility, whenever there is an error or any crash happened, I can immediately see, okay, this is where the application stopped. So I should be only focusing on that component instead of going back and looking into the other part of it, because they are not developed together. They were developed as the individual pieces, right? Did that add some logic?
Yes.
Okay.
Means
Now,
that actually Docker we must have to use in the microservices architecture only, or we can use in the monolithic also.
okay, so when Docker is the very first step actually, whenever you are creating a microservice, okay, so Docker is going to be very first step where you are actually taking some very lightweight base image. On top of that, you are going to add the dependencies, you are going to add your code. Okay, so you are whatever application you have developed during the whole process, like in this architecture. Okay, let me change this setting. Okay. Now this code, whatever you have developed here, okay. Now this actually will be created as an image only when you are passing it through a Docker, okay, or maybe some other similar tools, okay. So you will have the application code, you will have a base image on which you are going to use and deploy altogether this application. So it will take individual components. Let me, so here, yeah, so it is being shared. Now let me enlarge it a bit. Okay, so if you see here, I have this working directory, you can see, right? So this is where I'm going to pass on my source code, like the application that you must be working on your local system, that you are going to pass on through this particular, I mean, there are other ways of doing it. So like suppose I have this copy command, I will have copy dot is like my current folder where I'm working the workspace, and then I will have a folder where on the container image where it is going to actually copy all of this data, right? So image path, something like that. So now this is where it is going to actually store all of that application code. Then I will have dependencies also copied just below it, and then ultimately at the end I will just expose it with the set of command which will help me run that application. Suppose this is going to be a Python code, which I mean the application which is developed with the Python. So I will have this in the CMD or the last command, I will have the Python, and then whenever it is going to start executing, it will take only the Python as the input or the interpreter. With that, it is going to work. Otherwise, it is not going to execute. So similar to that, you will have it for the Node.js or the JavaScript or all sort of other application development. So for everything, it is going to be a similar structure, which is a Docker file. Okay. Once I have the Docker file developed, applications encapsulated in that, then all those dependencies, every component will be packaged together, and then it will be actually created as an image out of it. And that image, when executed, it will create a container or the microservice. Okay. So far clear till this three steps? Got the code, application, everything encapsulated, build the image, and from that you are creating a container or the microservice. So far that is clear, right?
Yes.
Yes.
Okay. So yeah, let's go back. So we were discussing, yeah. So now here, if you see the container features that we are getting, it is shareable, it is isolated, okay, it's a fast to deploy because you are just focusing on individual components. It is reusable because you can port it anywhere. You can port it to any operating system. I mean, any container developed on Windows can be, it will be working on Mac system, even Linux, everywhere, right? It is immutable, like whatever changes you made or the images that you created for one time here, okay, this artifact registry will store that images. Now that is not going to be changed unless you are actually going back and then reverting it. I mean, it cannot be, okay. So and it is easy to create multiple versions using the tagging and other techniques, okay. Now the now see this picture. So when you are using your own operating system, that is where you will have the hardware, the operating system dependencies, application code, everything will be present in this one particular part, okay. But when you are actually creating a virtual machine, virtual machines are created in your, like you use some software for creating the virtual machines on your operating system, but it is tightly you can say tightly linked with the operating system on which you are working. So it cannot be ported to other systems, okay. But when you are actually containerizing your application, so in previous screens when I was sharing, so I saw that I have that interactive Python running. I can have an application, complete application running, created in I mean, exposed it with the HTTP request. So now there I get a flexibility that I can host it on my operating system, but it can be I mean, it can be actually achieved, or it can be interacting with the remote places. I mean, someone trying from their operating system, so they can access it when I containerize and then expose it separately, right? So that kind of flexibility I'm getting with the containerization. Okay. Now, so let's move on. So what we have is, so I have a lot of containers. How can I orchestrate that? So the question here comes is, I got it that the Docker is used for creating the container images, and then I'm running it. I'm able to expose the services. Everything is fine, but that works fine when till the time I'm actually using just one particular container, right? But suppose I have thousands of running it, because I'm saying that whenever there is a monolithic application, there can be a lot many components. But when I break it into microservices, so it will be like hundreds of it, right? For individual tasks. So now these hundreds of things, how I'm going to manage? I mean, it's not, I mean, human a tendency to manage that many of components easily, right? So for that purpose, there is a concept of Kubernetes. So suppose you have hundreds of microservices spread out in multiple of tiers. So I have front end, back end, and the databases. So thousands of running there. I want to manage it properly. So there I want someone to supervision it or orchestrate it, right? So I want to orchestrate it easily, and for that there is a concept of Kubernetes. Okay, got it? So someone is actually taking care of all those I mean, handling part of it, the management of these containers, and for that there is a concept of Kubernetes. Now here, whenever we are talking about Kubernetes, it's an open
One
source platform.
question.
Yes.
One question.
Yeah.
So Kubernetes and Docker are same, or Kubernetes is managing many Dockers inside it?
Yeah, the second part is correct.
Okay.
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 Yeah. So Kubernetes is nothing but a management of those Dockers. A Docker created containers, not the Docker, but Docker has created a container for me, a microservice for me, right? So Docker is an other application which is helping me create the image, and the out of image I'm creating the container. Kubernetes is helping me manage these containers easily, so that I can actually scale better. Okay, I want to create 1,000 and lakhs of these containers and want to go smoothly whenever this is deployed to production, staging, wherever. Okay, so I want to manage that very well, and for that reason I have the Kubernetes. Clear?
Yes.
Concept wise clear, the foundation of it, right?
Yes. Yes.
Okay. Now this Kubernetes, if you see, it is actually available open source. You can try it out on your system. Obviously, just check what is the configuration it is looking for. Okay. And similar to that, now Google has developed its own Kubernetes engine. Okay. Now they are providing additional features on it. So with open source, you may lack a lot many of functionalities and how the costing will work, and how I'm going to monitor it well, how the logging is going to work, right? All those things, and how I'm going to load balance all of those components, how it is going to repair, right? So all of these will be taken care when you are actually utilizing Google's own Kubernetes engine. Okay, not much difference. That is the functionality you are getting, and there are multiple modes. Like they will have a standard and the auto mode. Okay, so with that you can utilize it. Fine. Okay. Yes, someone has question.
No, I just said okay.
Okay. So now, so far we got what is Docker, what is Kubernetes, why Kubernetes. Now, how do I deploy it or how do I use it? So, which I have already covered. If you see, so we talked about cloud code, how you store it into repository, then you run the cloud build command, which creates the image out of it, and then you are saving it in the container registry. I mean, not the images only, but now after the image, you got the container also created. That container will be present in the container registry. Okay, and that container is now getting deployed to GKE. Okay, in the previous architecture we understood that well. Okay, so and to access that, once it is deployed to Kubernetes, there will be another set of command or tool that you can use for working through it, right? So the command or the command line tool that you use, it is called kubectl. Okay, so kubectl is one that will be used for running, I mean, working with the Kubernetes. So for Docker, you had the Docker as the command, right? You saw that. So for Kubernetes, it is a kubectl. Okay. Before I go down, let's see a little more how this kubectl will be used for interacting with the Kubernetes. Okay, or how the Kubernetes architecture looks like. Fine. So let's see how does this GKE works. So we have the user. User is going to use this kubectl command on the command line, and this whatever command I'm going to pass on, it will be going inside this Kubernetes tool or the application. Here it is going to perform all those operations and give me the result based on what I have actually performed as a command. Okay, so it has its own API server, and it is actually saving all of those controllers, resource controllers, schedulers are present, right? All these components will remain common. I'm not going to go much deeper because obviously we are already going a lot of it for the Kubernetes side. I think this should give you the enough understanding how it works. If you want to explore it more, definitely there can be much dedicated session for it. But yeah, for now, let's try to understand what are the components in GKE or the Kubernetes architecture. Okay. Now the red part here, this is the master node, and this is the other one is actually the what you can say, it's a worker node. Okay. Now master node is going to control all the operations, everything that will be done on the worker node. Master node is not going to be accessible when you are working through the GKE. I mean, you cannot directly go and make any infrastructure changes or anything here. Okay, but only access that you will have is with the worker node. That is where actually you are deploying your containers. So far, whatever this container we are talking about all the time, this container will be deployed into the worker nodes, and within that worker nodes, you will have pods, okay? And within the pods, you will have these containers deployed, okay? So again, whenever we are working with Kubernetes, you will be working with the worker nodes. In the worker nodes, there will be pods. Pods will have the containers, and in an individual pod there can be multiples of container, not just one. So here the multiple containers are going to be, you can say, like I have a backend application plus database also in the same pod, okay? I can keep it there. If I want to have a separate one, that is also fine, but if I want to club it in one, I can do that, right? So I have that option, fine. Okay, now do you understand what is a node? Anyone wants to give it a try? What a node means?
Yeah, Jitendra.
Yes.
Like we were having like front end container, then back end container, and database container. Okay. So in node, like we will have pods. So every pod, like one pod will have this front end container. Then the other pod will contain the backend container and database as a one container as a pod.
Yes.
So this whole as a package will be a node.
Okay. So yes, that is also true. But let me put it another way. So
Nodes
whenever
we can consider like a one server is like that.
yes, that is more resembling. So
Okay.
nodes are one complete operating system.
Yes.
Okay.
So here
when
three
we
servers are there. You can consider like that. Inside that, we whatever the requirements are there, we have put it like that. Pods
yes,
are there, containers are there, like that.
right, right. Now, if you see here, the heading also you can read, right? So if I read it, Kubernetes engine container cluster in GCP. Okay, that is what this part of this graphics talks about. So whenever I say a cluster, okay, so cluster is made of multiple components, right?
Yes,
Now, what are
multiple
those components?
servers.
Multiple servers or multiple nodes.
Yes,
Okay.
both are same.
So one cluster will have multiple operating systems, if that is clear to you.
Yes.
Okay.
Yes.
Now, individual operating system can have multiple pods. Okay. So I have 3 operating system with me, right? It's up to me where I want to deploy, in which operating system I want to deploy my components. Suppose I want to use this one, the first one for front end, the second one, which is larger one, I would use it for the back end, and there will be the last one, which I will use only for the database part of it. So I'm going to dedicatedly use that node only for the database, right? So each of that node can be used for deploying my pods. I mean, creating the pods, and within the pods, I'm going to deploy this container. Okay. So altogether, this is how, on very high level, this architecture look like, and that is how the Kubernetes concept works fundamentally for any of the platform, not only for GCP, for any platform. Okay. Any doubts? No? Okay, fine. Okay, so far, if you got uh, some understanding how this GKE and Docker part works, now let's move on. What are the other ways of actually securing it also? I mean, there should be some way. I just don't want to deploy it otherwise, right? There should be some advantage of going with this approach, because this seems to be a lot of work. Why someone should take that pain, right? So here we get other services integrated with the Google Cloud whenever we are using GKE. So it will have the load balancing option, like we can load balance based on from where the request is coming, what sort of request is coming. Based on that, I can divert the a request to a particular microservice. Okay, I will have the persistent days, so that if suppose while the workload, I mean this pod or the container is performing or working on with my app request, okay, whatever, like I want to access some data, some website, and it is going to serve the request based on like it's if it is going to fetch something from the database, okay, so it is going to perform that task. Now suppose in between something wrong happened and it is down, okay, so where am I going to store that information? So for that I should have some way of storing those state information, which we can do with the persistent disk. Okay, so that will be used there. I will have the cloud monitoring for monitoring all of these components, so that I can easily track where the error could be. I can easily troubleshoot it. Okay, now, so once we have that understanding, now let's see how does the traffic is handled, or whenever the growth of the traffic is more, how we are going to handle it. So there are two ways. I think someone had talked about it. So we have this vertical pod autoscaler, and we have the horizontal pod autoscaler. These two ways that we can actually scale whatever pods we are creating, right? So these pods are nothing but again, inside the nodes we will have the pods, and that pod size can be, I mean, we can assign like how much memory, how much CPU we are going to allocate for individual pods, right? So that can be defined within those the pods, and it can scale two ways. Either we can scale individual pod vertically, like it can keep on growing with the amount of memory or the CPU, or we can have multiple pods and it will scale horizontally. I mean, one pod is done with certain number of CPU and memory. Now I don't want to overload it. I will create another pod if there is a need, because when work is done, I want to scale it down immediately. Like you have seen some Black Friday and other days, we have a lot of demands. So at that time, we want to ensure that only a particular days we want to have the scaling done properly. And once the day is gone, I should be scaling down from those components, right? Those pods. Okay. So this is for the pod aspect, but so pod is what from the workload side, right? Now, cluster is coming from the infra side, because this is the actual operating system or kind of multiple operating system that is making a cluster, that is providing me the infrastructure to run these workloads. Okay, so for infrastructure side, I should also have a option to auto scale my clusters. So here I had 3 nodes. Suppose now the need is increased, so I want to scale it to maybe 10 nodes. Okay, so that should be an option for me, and that is where this cluster autoscaler will work. Okay, and node auto provisioning should also be done, so I can automate how many nodes in a cluster can be created. So this is for node scaling, auto provisioning for within a cluster, but I can have multiple clusters also, right, based on my workloads. So I can do that also. So you see, so far if you try to get the visualization here, I have the flexibility at all levels. I have a cluster autoscaler where I can have multiples of clusters created. I have an option to create multiple nodes within those cluster. Then within these nodes, I will have the option to auto scale the pods. Okay, and within the pods, obviously, I have already created my CI/CD pipeline, which will help me deploy those containers within those pods. Okay, so container is somewhere you can say like it is present as a, I mean the application, it is stored as an artifact somewhere. Now I have built my infrastructure for as the Kubernetes, where I have the cluster node pod, and within that I am going to actually deploy this container so that I can work with my workload. That's all. Okay, clear?
Clear.
Okay. Now, how do you secure your apps using the GKE? So there are, I mean, these are also some side concern that has to be taken care of. Okay, where these are important, but let's not go much deeper here. But let's see what are ways that we want to secure it. So you by default you will have the data encryption. You will have the only the certified images. When I was sharing this Docker Hub, you can see that there were trusted images, right? So those are the images that I want to use. I will have the private cluster. Private cluster, when I say, so I'm not going to expose the IPs that we are going to create, or that the network how it is going to be created within those clusters. Okay, so for that I am going to only use the private IPs, and that's how I'm no one from outside of my organization or the cluster that I've created can access any of it, right? Then I will have to have the identity and access management created. IAM is on the Google Cloud side, RBAC is on the Kubernetes side. They are two different entities, right? Kubernetes is a separate entity which has to interact with the Google Cloud. So for that, there should be a way to interact it. That's a different thing, but they have a different set of controls in place. Okay. Now again, from the networking side, we already talked about the global BPC provided by Google Cloud. Global load balancing is there. Cloud Armor is something a separate service working with the front end. Okay, and we have a lot many network policies created which will help you to control who can communicate with what. I mean, I can control external to how the external entities are interacting with the services. I can also control which other project or which other services can talk to my Kubernetes component. So that can also be controlled here. And then the software supply chain. So that is more of the binary authorization, then vulnerability scanning, okay, and the managed services, all those. Fine. So this is all about Kubernetes. And yes, so let's move on. Before I move on, let's have some more checks on any questions. Any doubts?
So my question is, are we going to do all of this in our lab?
No.
On hands-on?
No, definitely no.
I mean, some part of it, or?
We are going to do a lab on compute instance creation. Okay.
Okay.
Yeah, compute engine instance creation. We are going to do that. Okay.
Okay.
The content that I'm actually going a little extra side is this is more on the you can say for the professional levels pathways, actually the learning pathway that we go with, right? So that is where it aligns. So it is going on the higher side. I don't want to stress out everyone. Okay, so let's go one step ahead and keep on focusing on individuals, like first to understand how these small services are working. The fundamentals are clear, then later we can move on with other components if you have a need. Okay, fine. So let me go back to the slides, or I can take it from. Okay. Okay, so we covered what is GKE. Okay, now similar to that, we have a cloud run also. I'm going to be a little fast here because there is not much to cover once we have done with the GKE. Only thing is that it is more going towards the serverless way of doing it. So in GKE, you had to provision a lot many components. You had the control with infrastructure, right? But when you are working with Cloud Run, here you get, you just need to create your container, get with your container and deploy it to Cloud Run. Like you saw with the Docker, right? So you had the image available, and then from there you got the container. That container you are able to deploy with Cloud Run, okay? And from there you are able to work with individual microservice, or maybe multiples or millions of the same replica, so that you can do, okay? It's pay per basis uses, okay? And the when you are not utilizing this service at all, so you are not going to be charged anyway. So the way it is going to cost you is only based on how many requests you have sent. Like this is more related to the web application that you may be developing, so you can compare it or get it much parallel with how app engine works. So we were looking at from the web development, mobile application development. So you can compare it similar to that, okay? So here you will be charged only for the number of requests you have sent. The number of API calls you have made, how much CPU it has taken while it was performing your request, how much memory it has taken, and what was the networking charges. Like we will cover that networking part, what is egress and ingress, but that is how the charging happens with the Cloud Run. But apart from that, it has not much differences when you compare it with the Docker concept, okay? I will share you the link so that you can go through it. If you have any questions on this, you can get back to me.
Jitendra, like GKE was handling multiple containers, right?
Yes.
So same way Cloud Run also handles, or it's individual?
Okay, so here it can also handle this multiple containers, okay? But it will have the similar components. It will be more of web application perspective. It will help with splitting the traffic, but here you don't get the concept of pods, node, cluster, all those things. You won't have that visibility. You won't have that control in place, okay? Here you are only taking one container, okay? So that container you must have developed in some other cloud also on your own premises, or you must have developed in the Docker desktop itself, right? So that is the individual part component. Now you want to deploy it in the Cloud Run. So you will take that image itself. It will be packaged like .zip or something. You will take it and you will just deploy it to Cloud Run. Okay, so the Kubernetes concept will not come here at all. Fine. Okay. You can, I think, consider it with something like in AWS we have Fargate, right?
Not used.
Okay. Then just focus on Cloud Run and then try to explore it a bit more, what it does. Okay. How to use, you can see here. Write your code and you can package it with the cloud build, use the cloud pool, create a container, and then you deploy it to Cloud Run. That's all. You are not going with any picture of a GK in and all those concepts. You just have the Cloud Run and it will deploy for you. See, I will try to get you access to some, not access to, but I can point you to some quick labs also on that where you can try it out, okay? But for this particular training, it is going to be a lot many things. So and we are going very slow, okay? And also this is not the need for this fundamental training actually, okay? So let's talk about the cloud function. Now cloud function here, if you just see, you will have to work with just individual function or individual method instead of that whole application we saw in previous slide for containers, okay? So you are packaging all the dependency, everything. You don't have to do that here with the cloud function. Cloud function is just a piece of code. You get an interface on the cloud function. You will write your code. It will be performing just individual tasks. Okay. So suppose you want to actually, I said that, okay, let me share this one. Hold on. Yeah. So in this architecture, as I talked about, like we will have something to trigger, right? So here, the cloud function, which is just one functionality, it will see that, okay, there is a new repo created, a new code was checked in. Okay. As soon as it will check that there is a new code in place, it will trigger this functionality, cloud function, and it will actually going to communicate with the cloud, will saying that, okay, we have a new update available. Can you just take care of it? I mean, you can create the container out of it and then save it somewhere, right? So that is what it is going to do. So that's an individual piece that cloud function performs. Okay, fine. Now let's talk about where should we run this stuff. You have to come up with your use case and you have to tell me where should you use what. Let's start with okay. So let's start with Vishal. Vishal, can you tell me where would you use this compute engine?
Compute engine.
Yes, compute engine is a infrastructure as a infrastructure as a service.
In my daily work, I think related to my production environment, can be used to run the all ERP systems, and
Yes.
then related to ERP were like materials management, quality management, or let's say production planning. All of those are part of this.
Right.
Yeah.
Yes, that's true. Even for SAP application also we use compute engine. So it is a complete virtual machine, you can say. Okay. With the virtual machine, you will have some constraint as well. Like suppose I had some licenses that I purchased when I was working with my on-premises. Now, whenever I'm going to migrate to the cloud, actually it is still active, and and we have already paid our some charges for it. So I'm going to bring that same license, and for that purpose I need to actually go with only the compute engine, where I can utilize that whole operating system and I can use that. Also, the other scenario can be I have a need for a custom machine which I want to use for my workload. For that customization, I'm going to go for the compute engine, or I can also go for the Kubernetes engine, where I can create a customized operating system as well, with certain dependencies, application, or some more components. So that is where I'm going to go for compute engine or Kubernetes engine, because they are giving me more of flexibility. But obviously there is going to be more of operational requirement for me, right? Now let's talk about okay. So let's see, Vijay, can you tell me in which scenario you are going to use Kubernetes engine?
Sorry, Jindra.
Yeah, so I was asking in which scenario you will use Kubernetes engine.
Okay.
Okay, no problem. So
yeah.
In
yes,
the
you want to
deployment, I
attempt?
think we will use Kubernetes, I think.
Where?
Google Cloud Deploy.
No, I was asking from the perspective of the use case that you may have in a scenario, right?
Okay.
So Kubernetes engine, like when you want to containerize your application. I mean, when you want to create a microservices for your application instead of having a full-fledged monolithic application in place. So if you want to create a application which is going to be more on the containerized form, that is where you will use that. Is my screen not changed? Okay, give me a second. I think I'm on a wrong screen. Okay, so I was talking about this particular slide. Okay, so we covered about compute engine. We talked about Kubernetes. So we want to containerize application. We will have this hybrid or the multi-cloud deployments. So suppose I'm working with my on-premises, or some of my applications are running in the on-premises like a data center, the on-prem data center. I have some components deployed in a different cloud, maybe AWS or Azure, and there are some components which is only working in the GCP. So when I have such an environment, a hybrid environment, so I'm going to use Kubernetes, which gives me more flexibility to deploy it anywhere based on my use case, based on the availability of those scenarios. Okay. So some of it I'm going to deploy on the AWS, some will be deployed on GCP, and some on the Azure. Okay. And that can be done using the Kubernetes concept, because here the containerized application or the container that I have created, that is portable, that is flexible to be deployed on any of the platforms. Okay. And again, same thing for cloud run and cloud function. So they are giving you not the flexibility, but they are more serverless. I mean, the operations that you need to perform, that will be very limited. Okay. So you can just read through these controls, right? So you get more controls when you are working with Kubernetes or compute engine. You are going to have less control when you are working with cloud run or cloud function. Okay. Then the operation overhead will be more when you have the compute engine or Kubernetes engine. But with the serverless components, everything is actually managed by the cloud itself. I had shown you the shared responsibility model, right?
Yes, I have gone through that one.
Everyone able to recall the shared responsibility model graph that we have seen?
Yes.
Yes.
Yeah. So now relate it here. That's why I was saying that it is very important. Now, if you see here, based on the shared responsibility model, if you see here in the left hand side, you will have more of the controls, but more of responsibility as well. But as you are moving towards right, the responsibilities will be less. You will have less control as well. Okay. So that is how it works. On the left hand side, you will have to have go with the committed resource uses, like we talked about in case of compute engine. You will have to commit it for 1 year, 3 years, 10 years, like that, and it will give you more of a discounts. But in case of serverless component, the costing factor goes into a uses based, like pay per uses. Okay. So as much you are going to use, that much only you pay. Otherwise, you won't be charged anyway, right? So this is how this particular this is how you define where you want to actually deploy your code, which service you want to use, or you can have a scenario where you will be using multiples of it. I mean, some of the components you will deploy in compute engine, some will go into Kubernetes engine, some of it will go to cloud run, and for triggering some components, I want to use cloud function, right? So which is based on the event driven functionalities. Like there is an event happened, a new code is available in the repo. I'm going to trigger the cloud function so that it will trigger the cloud build to create the image and the container out of it, right? So that is how these all services are working together. Okay. So that is all about the presentation side of it. Now let's see if we have already exceeded. So let's see if can you go with okay. So let's conclude it here for today, and tomorrow we'll be doing the lab and cloud storage plus the lab for cloud storage also. Is that fine?
Yeah,
Yes,
yes,
fine.
absolutely.
Yes, fine.
Okay. Fine. So let's conclude it here itself, and we'll start our day 4 where we will do the labs. And yeah, so tomorrow we'll be doing it. Let me stop the recording.